Okay, guys, glad I caught that before. Make sure we didn't interrupt any coding. Okay, glad I caught that before we tried it and it didn't work. So this guy, pin 5, he needs to go just straight to ground because we're not going to read from the LED. We're just going to LCD. We're just going to write to it. Of course, if we did decide to read from it, it would be an input. Okay. Okay, so here we are. We just put in hours. I'm actually going to save this. It shouldn't allow me to save over it. Let's test that. No, see, it's a read only because it's an example as part of the library. So let's save this as, and we want to go to our Arduino and our Arduino tutorials. We want to say LCD test. And okay, if we look at our LCD test, this tells you all this. We've actually changed these pins. So RS, enable pin, D4, D5, D6, D7, LCD read write to ground, 10K resistor for the 10K resistor for the contrast, 5 volt ends to ground, wiper, LCD, VO pin, pin 3, which is, that's the contrast. This is the information about the library. This is where the library is. This is the include file. This is our setup. This is our LCD. We're telling it what pins to use. We can choose. We don't have to use these default pins up here. This is our setup, LCD begin. And this is where we choose what type of LCD, the number of columns and rows. We have 2 rows, we have 16 columns. We have 16 characters across, 2 rows going down. We could have 4 rows if we wanted to. And then we have a message that we print. And we're printing hello world. That's usually what your first message is. Actually, let's change that. We'll say hello. Make it personal. Hello, Scotty. Down here we have a loop, and we have the set cursor command. And then LCD print number of seconds since last reset. So we're printing the millis. So let's actually open up our reference guide. And let's push it over a little bit here so we can see both of these. Actually, I think I can pull this over a little without losing too much. Okay, so if we look at our reference guide, we have to go to libraries, and then we see our liquid crystal library. And here's all, if you want to know what any of these are, like LCD set cursor, if you notice, liquid crystal, we called it LCD. We can call this anything we want to. I guess we could change. Well, actually, I want to get it working before I start changing things, just in case we miss something. But you can name this whatever you want. You can have multiple LCDs. You can have it LCD1, LCD2, have it called Michael. You know, Timothy. This is the Betty LCD. Call it anything you want. And then down here, you would change that to whatever that name is. Same thing here. So you would use your different instances of LCDs. So that's only a name. Don't worry about it. You can name it anything you want. We happen to name this one. This one's just named LCD. So if we look at begin, so it's LCD begin, it gives us the description of what it do. LCD begin, columns, rows. So we have 16 columns and we have 2 rows. LCD print, that's printing to our LCD. That's sending text, prints whatever text we put there. And right now, that is just text that we're sending there. Pretty soon, we're going to send some variables to there. Here is they're sending the variable of milliseconds divided by 1,000, so it shows the seconds. So if we go back, we can look at set cursor. There's a whole bunch of other things here, too. So if we look at, where is a whole bunch of different examples. I don't see the set cursor command. I see cursor command. LCD cursor or no cursor displays it. I tell you right now, the set cursor command is what it's doing is it's setting it to a column / row. So it's not here, but so what it's doing is we have 16 columns, so it's going 0 across. So, and then number 1, our first row on the LCD is 0. So if this was 0, 0, we would be displaying to the first row. Let me go here. Let's go here. So here is the columns. So there's 16 of them. This is 0, 0. This is 0, 1. This is 1, 1. This is 2, 1. This is 0, 3. See, because 0 is there. 0, 1, 2, 3. So 0, 3. So that's how these work here. So that's what we're setting it. We're setting it below, and then we're changing it. You notice we don't have to reprint this. This will stay there. We don't have to reprint that. This setup is what you do once, and loop is what repeats over and over again. And this hello Scotty will stay there, and then you will see the time increment. So we've made our changes. I think it's time to upload to our LCD and see our test. And then we're going to go to our IR sensor, and we're going to actually, we'll rename this now, save as IR sensor _ with. Now I can put a space and just type in LCD, and it'll change the name. It'll put an underscore there for me. See, it has to put it in there. So, and then we'll change this sketch so that we see the sensor value on the LCD displayed. And we'll call it sensor value. Up in our setup, we'll put infrared sensor, and then down below in the loop, we'll repeat what the change is. And we may have to put a delay in there because it may change so fast that it's unreadable on the LCD. But we'll see. So anyways, let's plug in our Arduino. Our Arduino is plugged in. And a couple of things we have to make sure first. We have the correct board. It is a 328. And the serial port, I only have COM4 in there, so yep, that's it. So now let's upload this. And keep our fingers crossed. So it's uploading to the board. And I'm going to pause this and we'll go over to the video. Okay guys, I don't think I uploaded to the board. I think I just compiled. Let me make sure I upload to the board, because I noticed a green LED on there. And instead of reviewing the video, I can just send the upload. Okay, done uploading. Yes, now we're good. Okay guys, we are, let me shut this off. And we are actually quite good right now. You'll notice, I don't know if you can see that, but let's zoom in. And our LCD says, hello Scotty. I should have probably put a capital H there. And if you notice, it's incrementing the time. And I can tell you right now, just from looking at the time incrementing, let me see if I can bring this up a little. I don't know if you can tell from the video, but I can tell that we're going to have to put a delay in for our because of the refresh rate on the LCD, otherwise it'll probably be unreadable. Now let me adjust the contrast. Yeah, I think that's actually better. So the contrast is adjusted. And right now we're going to go modify the sketch for the infrared sensor, so we can get infrared sensor readings on this instead of just this. And then we will test the resistor. So right now there's 102 seconds have passed. since I uploaded this sketch. Just before we go back, I noticed where I had to go look for this baby for powering the Arduino. Just so you know, of course it's going to change once I take it out of the Arduino, but now with our projects, once we've uploaded our code, we can actually power our Arduino from another source. I've disconnected it from the computer, and of course you notice how it starts over again. But now we're no longer connected to the computer. The Arduino is no longer connected to the computer, and now we're functioning without our connection to the computer. And you'll notice when we do our sensor reads, I'll be able to see those without, connecting to the computer. So, okay, guys. As you just saw, we were running with our LCD, and everything was working great. Now, if we come over to our other sketch over here, and I'm hoping what you're seeing here is fantastic as far as detail is concerned, and I'm hoping it's not my video editing software that's killing this. Because when I look at this alone, it comes out fantastic, and we'll see what happens. Anyways, I've bumped up the resolution and the speed as high as I can for the computer itself. Okay, so let's do this ourselves. Let's actually type this in, because I got to tell you, that helps a lot. Now, like I said, for here, we can either go Sketch, Input Library, Liquid Crystal. Boom, it's there. And it doesn't even have to be that at the extreme top. We can just type it up here, pound include less than liquid crystal.h less than. Okay, so there's our library. Now under void setup, we're going to leave the serial in there for now. Let's have the ability to do both. So in our setup, now what we want to do, before we even get to the setup, under this, we want to, and actually let's include, so we're including the library code. Let's document this. Pins we will use. And just for time, because this is already long, I'm going to take this. Okay. Now if you remember, if we want to comment a series of stuff, just go down here and then do star / Now that's all commented. And the pins we are using, let me go over here to see the pins we're using. We are using 8, 7, 3, hey, that one's the same, 5, 6, that to ground, and that's pin 3 and on the LCD board. I think that's a little clearer. It's not pin 3 on the Arduino. Okay, because we're using pin 3 for D4. Okay, so we've got our liquid crystal display. Next thing we need to do is liquid crystal. We're going to do my LCD. Now everything has to be my LCD after that. 8, comma 7, comma 3, comma 4, comma 5, comma 6. Now just to be legible so we can read it. Okay, now under setup, you know, so we're using these other pins for other things. Now under setup, we're going to include our LCD print command. Whoops. Sorry. It's my LCD dot set cursor first. Oh no, I'm sorry. This cursor's already set to we got an LCD begin, just like we serial begin down below, and then we tell it what it is. It's 16.2. If we had a 16.4, we would put 16.4. So this is a 16.2 LCD begin. So number of rows and columns. Here we go. Now it prints to this once, and we don't have to do it again. And we're going to call it infrared. Yeah, we'll just do it all lowercase. Infrared sensor. How many we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. That's it. We can put a colon and then 16, and that's it. There's our 16. Now you got to be careful. Some of these LCD displays, if you go beyond 16, some of them just cut it off. Some of them, like on the 16.4 display, some of them word wrap to one row. But basically, that's it. Infrared sensor. And down here, see where we have the print for here, we're going to have print the sensor value. And it's going to be, well, first we've got to set the cursor. Set the LCD cursor to the second row, which is 1. Yeah, I know it's confusing, but once we get into the programming, everything starts at 0. And if you remember that, you will be much better off. So we've got my LCD. Everything should be my LCD. If I do anything LCD, it won't work. Which is why I normally don't do this, but I want to show you guys what I was talking about this. Set cursor to column 0, row 1, which is actually row 2. And did I spell cursor wrong? Yes, I did. And then print sensor value, which is if you notice here, it's print line, and then it continues on. If we just did print, it would be continuous across. But here, there's no print line. Here, you set where the cursor is. And then to print the value, to print text, you put it in quotation marks. To print a value, you just type in the variable. Now, what if you wanted to do a variable and text on the same line? What you would do is you would do a plus, and then how much do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, space 12, 13, 14, 15, 16. Now we'll print the value space test, or it should. Let's experiment. Let's see if this works. And that's in the loop. And it's already set for our infrared values. You know, we did our values here. We're using the same exact sensor, so this should work like it worked in the rest. But I promised that I would review this code. So here we go. We're including the liquid crystal display library. We're writing pretty much C code is what we're writing. That's why you see this .h. You see that a lot in H. We're changing the pins that we're using for our liquid crystal display. This is the RS pin, and it's just the order they go in. The RS pin, the enable pin, D4, D5, D6, and D7, which is 3, 4, we're setting it for pins 3, 4, 5, 6, respectively. We initialize the library with the pins that we will use. This actually should have been above that, so it's good to review the code. Okay, then we're setting our LEDs. Our LED is going to be digital pin 9, our green, our yellow 10, our red 11, our buzzer 12, our IR sensor. This is analog. And I will get these uploaded. And then our sensor value, we start as 0. Our void setup, pin mode, green LED. What's green LED? Pin 9. So pin 9 is going to be an output. Pin 10 is going to be an output. Pin 11 is going to be an output. Pin 12 is going to be an output. So it's either going to be 0 or 5 volts. LCD begin. We initialize the LCD. We tell it we're using a display with 16 columns, 2 rows. We print the message on the first line of the LCD, infrared sensor. We have 16 characters to do with it. There's our 16 characters right there, not including the quotes. Serial begin. We open our serial port in case we want to use the serial monitor. Void loop. This is our loop. So this is the end of our setup. See how it highlights that one when I select here? This is the end of our setup. That's a curly brace. These are parentheses. This is a curly brace. So sensor value equals analog read IR sensor. IR sensor 5. Remember, we plugged it into 5. I was right. If we plugged it into 4, I would just change this number here, and it changes everywhere else in the code. Okay, so we analog read infrared sensor, which is pin 5. So analog read, analog pin 5, store it in sensor value. Then we print it to the serial monitor, the sensor value. We don't have a delay in there. We may have to put a delay in there. Actually, I might even put a delay in there now. Let's actually put a delay. That's 100 milliseconds. So let's put the 100 millisecond delay in and see what happens. Now, of course, as I move my hand down, the readings aren't as accurate because there's a 100 millisecond delay in our readings. So my LCD set cursor. So we're setting the cursor to column 0, which is all the way over to the left, row 1, which is actually row 2. So it's the second row. Then my LCD print, and we print in sensor value plus test, just to show that you can do both a variable, and actually I counted that wrong because the sensor value is not going to be that much. So 1, 2, 3, 4. So we're not printing this, we're printing the value, which is 0 to 1023. So I could actually fit a lot more on that line. Okay, then down here, if sensor value is less than or equal to 100, then turn off the green, turn off the yellow, turn off the red, turn off the buzzer. If it's greater than 100, but less than or equal to 275, turn on the green, turn off the yellow, turn off the red, turn off the buzzer. If sensor value is greater than 275, so it won't do both, because here's 275, so it's less than or equal to. If it's greater than 275, or less than or equal to 450, turn the green LED on. That's what high means. High means give it power. Low means set it to ground. So turn on green LED, turn on yellow LED, turn off red LED, turn off buzzer. If it's greater than 450 and sensor value is less than or equal to 600, turn on the green LED, turn on the yellow LED, turn on the red LED, keep the buzzer off. And finally, if it's greater than 600 and it's less than or equal to 1023, we really didn't need this. This right here we did not need. I could actually delete that right now and it would make no difference. But we're going to leave it in. Then turn them all on. End of story. And of course that works with this one. This one, if I highlight this, that works with that one. This one is this curly brace. So that reviews our whole code. So now we hit save because we've already renamed it. So now we save it. Let's compile our code, make sure there's nothing wrong. Compiled. Now let's upload our code. Sorry, I know when I did this one, I think I compiled it and didn't upload it. So now let's upload the code. And now that I see it's uploading, there it goes. And as soon as it's there it is. And we're getting garbage. Okay, I see it says infrared sensor, but we're actually getting garbage for the second line. So before we move over to the video portion, let me delete this because that's not working. And let's take a quick look at the reference. I know in processing, I do a lot of programming and processing too. So sometimes sometimes these things are transferable, sometimes they're not. Liquid crystal, print. Okay, so we have base, optional, base in which to print numbers, bin, binary for bin, base 2, decimal, octet, hexadecimal. So I don't think it's going to allow us to combine the two. I could probably do another line, and actually let's do that. Okay, so that failed. So, so let's do another line. And just for time's sake, I'm going to do a copy-paste. Actually, I'm going to do this. Okay, so now I want to set the cursor to, say it's 4, so let's set it to 5. And let's do test. So I couldn't put it on the same line, but now let's move the cursor over 5 and see if I can put it there. And let's test the code. Compiling. And when it compiles, it takes out all this stuff where it says sensor value, puts all those numbers in there. It actually translates it to more like machine language. Okay, let's upload this code. See if this helps any. Hey, it's working now. And actually, it is legible with the 100 milliseconds. So let's move over to the video camera. Okay, so we changed. What I did was I added another one. See, I couldn't do sensor value plus, so I added another one of these where I changed the cursor. But now I want to get rid of the test. So what I'm going to do is I'm going to just delete this. It's here. Hit pause if you want to see. Remember, it was showing the sensor value, and then we went 5 over and we displayed test. But what I want to do is I want to put this towards the middle. So it's going to be up to 4 characters. It averages around 3 characters. So why don't we move this over to 5 anyways and see how that is. And compiling. Don't hit upload because until it's done compiling. So everything looks good. Uploading right now. And let me pause this. Okay, I'm jumping back and forth so much, guys. I'm not sure what I showed you and what I didn't, but I put in a delay. I put in 500 milliseconds, or half a second, because when I had 100, it really wasn't that legible. I mean, I could use it, and I could use it practically, but it was much better with the half-second delay for the LCD. And actually, if I was using this as like a temperature sensor or temperature and humidity or almost anything else, I'd put a second delay in there. And I could, but you know, if you're using an infrared distance sensor, I mean, you don't want a second delay in your sensing of the distance. We just happen to I have everybody screaming for do outputs, do outputs. Oh, by the way, our next outputs are going to be motors. We're going to do a stepper motor, we're going to do a servo, and we're going to do a DC motor. So that way you guys can start building your robot projects as well. And then I'm going to get into the wireless and the Ethernet. The Ethernet first, because we're going to rebuild the plant that you can water over the internet, or that will water itself if you even forget to do that. And I think that's it. Let me save these. I will be posting these codes. I got all the code. I should just post it at one place and let you guys pick at it. But I try to format it into the web page for my hdvidi.tv site. But anyways, I hope you enjoyed this video. And the next one's going to be an electronics video. And then I'll do motors for output. And then we'll do some more input and output. And start doing some more complex projects. Okay, guys, it's working. We've got it. Our infrared sensor is working, and if you notice, now it's really maybe not that legible. It's changing a lot. You know, you notice it bouncing, that infrared sensor. So it's actually hard to read. I don't know if you could read that. Let me zoom in a little. I might want to increase that delay a little. And this may be one of the reasons you still want to use the terminal instead of the LCD for testing sensor ranges, because you know, I put my hand over this to get the different readings, and you're looking at it. Let me see if I can prop this up here. And zoom out just a little bit, so we get this in too. So there's our buzzer. So we're getting the readings. Now, I don't know how you're seeing it. I'm seeing like 152. So I could kind of make it legible. And then, of course, there's our yellow. And it's like 29. You may see it flip a little. And then there's the red. And then, of course, there's the buzzer. So we see in our LCD now, and with our different buttons. But while this is on, I'm going to go increase that delay a little and see what happens. Of course, if you're doing like some kind of sensor reading, you know, a second may be too long between these things. I'm going to bump up that delay to half a second and see what happens. So we're going to call it 500 milliseconds. And I'm going to save that, and I'm going to upload it. See, now you get to see the upload. See with the Arduino, I don't know if you can see it, but the little transmit and receive lights, it might be blocked by one of the wires. And of course now it's a half a second. And now it's much more legible, actually. And hopefully you're seeing that as well. I noticed some of the wires are in the way here. Okay. And I'm going to try to do this at 30 frames a second. But this is much more legible to me every half a second. But of course it takes half a second. If I went like this, it takes half a second for that sensor to adjust to it. So if we're like doing things like measuring the speed in which a laser bounces off an object, which we will be doing in the future, by the way, that's not going to be accurate. So we got infrared sensor, we got our thing, we've got our test, but it takes a half second. So, you know, when we're testing, you know, the speed of a laser bouncing off of something, we're not going to get it takes a half a second for it to adjust. But so that we could see our LCD, let's say if we were doing temperature and humidity and that kind of sensing, then this would work perfectly fine. And like I said, the LCD is actually, it may look like if you look at it at an angle like that, it looks like the contrast ratio isn't adjusted. But when I put it like this, you can actually see if it's dead on. There's the contrast ratio. And this is the button for the contrast ratio. And of course, I could adjust it so it might even look good at that angle for you guys. But, okay, now, as I promised, and this video is probably getting all my videos are long. I think that's why I use Vimeo. You can't use YouTube for long, high-def videos. Let's go to ohms on our multimeter. People who watch my electronics tutorials, which you should probably watch if you're doing Arduino, know what we're doing right now. We're going to test the ohms. We're going to take that potentiometer out of there, and we're going to see what kind of resistor. Instead of having the potentiometer, I'm going to pull it out, and of course everything disappears. And we're going to put it on one end, and we're reading 2K ohms. I forget which side we had it on. The positive is on the left. So 19. So I could put a 20K resistor in there. 20K? No, that can't be right. 20K. Maybe I had this in. Okay, so that's the power. That's the ground. So I want to go from the center to this guy here. And just so you can see, yeah, that's 20K. Well, we measured it. If we went from the ground, though, I think it's more reasonable. I would try a 2K resistor in there first, because when I measure the opposite end of this, I get a 2.2K. I would try a 2.2K resistor in there first. Or you can keep the trim pot in, and you constantly have the ability to adjust the contrast depending on the angle of visibility. Maybe it was this way. Here we go. Come on, get in there. There we go. Get in there. Yeah, I guess you get what you pay for. Okay. Bend him up, bend him back. And bend him back. Let's see if we can get this in there without breaking it this time. Yeah, it doesn't go into the breadboard very well, this particular trim pot. Actually, I had another trim pot that I was using and I couldn't get the resistance right. That's this guy. But we can actually try him. Hell, let's try him. Then we can measure his as well. So let's go power red. And then the middle one is the middle. I don't think this is going to work because it's only a 500 ohms. And yeah, works fine. This is a 5. Okay, we'll get a more accurate reading out of this guy now. Now, here we go. This guy's only 500 ohms. I mean, sorry, not 500 ohms. Yeah, he's only 500 ohms. I believe, when I measured him. We'll measure him again. So, works fine. Come in again, and you can see that if I, give you a more head-on look at that, and that would almost be perfect right there. And let's go here and here. One end of this we have 8 ohms. It's got to be the other one. 412 ohms. So 470 would probably be too much. But you can mess with that yourself. Decide what you think is the best. Let me put this back in here. For a small little project, it would be nice for just a... I mean, you don't need such a big trim pot for such a small little LCD. Okay, so we got the other trim pot in again. That's it. We're seeing our LCD. Infrared sensor. I'm going to do one more thing, and I'm going to keep on the... I'm going to keep on both videos, I guess. Okay, let's come over to here. Okay, so we changed, what I did was I added another one. See, I couldn't do sensor value plus, so I added another one of these where I changed the cursor. But now I want to get rid of the test. So what I'm going to do is I'm going to just delete this. It's here. Hit pause if you want to see. Remember, it was showing the sensor value, and then we went 5 over and we displayed test. But what I want to do is I want to put this towards the middle. So it's going to be up to 4 characters. It averages around 3 characters. So why don't we move this over to 5 anyways and see how that is. And compiling, don't hit upload because until it's done compiling. So everything looks good. Uploading right now. And let me pause this. Okay, it's not exactly the middle, but if you noticed, it's actually moved over now. So you can play with the LCDs, play with what you display, where you display it, and this is one of the nicer LEDs. I didn't have a cheaper LED on me here. I actually had a couple in work. I'm at home right now. It's Saturday. Sunday. Thank you. That was my wife. If I had one, I'd plop it in here because it would work identically. Okay, I don't know where I'm going to fit this in, guys. I noticed this at the end. What was happening with the sensor value? Well, let me see if I can show you. On, let's just use Notepad and I can do an example on that. I hate that bright white. It probably kills people's eyes in the videos. But... So when it was printing out the sensor value, let's say it was printing out 125, and then the next time it was printing out, it was 67. It would keep that 5 in there because it would only print over those first 2 characters. So it looked like it was saying 675, even though it wasn't. It was only 67, but it wouldn't blank out that 5 there. So what I did to resolve that was, see this? Now it starts printing out at 5, 1. So 5 over and 1 is actually row 2. So it starts printing, it prints out the sensor value, and then I have it immediately print a bunch of blank spaces. And I could have it go all the way to 16, it doesn't matter. So now what happens is if it prints 125, and then the next thing is 67, it'll print 67, or actually let's do the 125. It'll print 6, 7, and then it'll print space, 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 space. So it actually gets rid of that. So this, don't save that. So this is the final code right here. Let me save that. So you, after your sensor value, you want to print a bunch of spaces. If it was the same, if it was 3 characters the whole time or 4 characters the whole time, it would be fine. You would never see this issue come up. But since it only prints 3 characters, and then if the sensor value is low, it prints 4 characters. So it looks like it was saying 670 to me, even though it was only 670. Even though it was only 67, the lights weren't coming on, but the LCD was actually reading the higher value. It wasn't reading the higher value. It was displaying 67, but it kept that of the character. If you notice, up here, we only write this character once. We don't keep writing it over and over again. Everything in setup is done once. Everything in setup is done once, and everything in loops again and again and again. So we don't have to keep printing out to this. So the problem is once we print out the sensor value 3 characters and then we only write over it 2 characters, then it shows up. Oh, okay. Now that we have the sensor, let me unplug it from the computer. See, everything goes dim. And now I'm going to plug in the power, 9-volt power, to the Arduino. So this 9-volt battery is powering the Arduino, the LCD, the LEDs, and the sensor. Oh, I think I lost my sensor here. There we go. I lost the sensor. So now it's powering all of these, and let's see if we can power the buzzer too. Yep. So now the project is completely autonomous from the computer. And that half a millisecond delay is great. Okay, I'll show you that guy on the computer, and that should wrap it up for this tutorial.